Before we start regarding mixing of ice, water or water steam, we'll try to eradicate some misconceptions. Mostly it is understood that specific heat is almost similar for all substances, but no, it is the characteristic of material and depends on the material. It is intrinsic property and different for different substances. Second misconception is that mostly people or students feel that calorimeter is not going to absorb or transfer in amount of heat, but calorimeter is taken that of copper, and that does take part in this process that will either liberate heat, transfer heat being hot, or when temperature is less than liquid inside it, then it will accept the heat. Third thing is that during change of a state, why the temperature doesn't change. Actually, it's already clarified that during change of state, heat absorbed is used in the process of breaking the bonds and not in the process of expansion. Then we will consider the mixing of ice and water. Suppose M ice and M water, their masses. Water at temperature T degrees Celsius having a specific heat Cw is mixed with M ice that is at 0 degree Celsius. Then two possibilities are there. You see, water is hot, then 0, no doubt. Then water will release the heat and ice will melt. Ice is likely to melt. There are two cases of our interest. One is that complete ice is melted with the help of this water depending on the mass and temperature. Or second thing is only a fraction of ice is melted. Just suppose only few quantity of the ice is melted. Suppose the ice that has melted is M. M mass of ice has melted. So, when this will melt, it will require the heat ml. Mind, only m mass of the ice has melted. So, heat required is m into L, L latent heat of ice. And this would be given by water, its specific heat. And obviously, temperature will go to 0 degree because ice there is at 0 degree. So, this is minus 0. The mass could be calculated mw cw T upon L. This is the mass of ice that has melted. Mass of ice melted. What will be the temperature of mixture? 0 degree, because water will come to 0, only then mixture could be formed at the same temperature. And some of the ice has melted. Now ice remains here is M ice minus M. This is the ice left now. And what is the quantity of water? It was already MW plus M mass of ice has melted into water. So, this is the final quantity of water in the mixture. Now, suppose complete ice is melts. When complete ice melts, it will be melted and will be getting water at 0 degree, and this water will release the heat, supply the heat, deliver the heat by going to 0 degree. Then again the final temperature of the mixture is going to be 0 only. Same logic or same principle you could apply for combination of water and steam. Water MW, steam MS, this is 100 degree, and water here is at TW, its specific heat CW. there are two things. Water at T degree Celsius, TW degree Celsius, steam at 100 degrees Celsius. If you bring them into contact, only two things are possible. Either this water, you see this water, this is at lower temperature, it will receive the heat from steam. To give it or to supply the heat, some of the steam may condense into water, or it is likely to condense completely. When only fraction of the steam has converted into water, suppose m gram steam has converted into water, then it will liberate the heat m into L, but latent heat is that of vaporization, that is 540 calorie. In case of ice, we were using 80 calorie per gram. And here this water, this is to be heated up to 100 degree in order to make the temperature of the mixture same. So it will be heated CW, T is 100 minus TW. Initially it was, see, this is 100 minus TW. You could find this value of mass of steam that has converted into water, but the relation you are going to use is this one, MW. MW CW 100 minus CW upon L, and sorry for this is L. This way you could find the mass of steam that has condensed into water. Then again, as in the previous case, in the case of water and ice, suppose the complete steam has condensed, then also the final temperature is going to be 100. This will be completely reached to 100 degrees Celsius and steam was condensed, but temperature of mixture will be again the same value, that is 100 degrees.